Okay, so 4-5 is writing the function rule. So the whole idea, we're not going to solve this pretty much anything today. We're going to read it and translate the words into an equation of some sort. Okay, so we're just going to practice. There's only 3 practices, and then I'm going to help you at least get started on the assignment, and we're going to do some of that together. Okay, so here's the first one. You can estimate the temperature outside by counting the number of chirps of the snowy tree cricket. We can look that up later. The outdoor temperature is about 40 degrees Fahrenheit, more than 1/4 the number of chirps the cricket makes in 1 minute. So, what is a function rule that represents this situation? All right, so you got to make that. Basically, we don't want any words. We only want equal signs, time signs, addition signs, and variables and numbers. That's it. So, what do you think is important here? 40 degrees. Yep. Okay. 40 degrees. We need that. We might need more than, right? That seems like it's important. 1/4, yep. And 1/4 of the number of chirps, right? So that we want to know what that's going to be in 1 minute. Okay, so let's talk about this a second. Usually we use X and Y, right? So in these, a lot of times it's helpful almost to use other variables. You can actually use whatever letters you want. So let's talk about 1/4 the number of chirps. Do we know how many chirps they're making? So that means a variable, right? So we don't have to use X or Y. We can do 1/4 and we can use C for chirps or N for number, right? What does 40 degrees more than mean? What are we going to do with that 40? Plus, yeah. And does it matter if I add 40 on the front or the back?
No.
It doesn't. Addition is something called commutative. So, like, if you add something, it doesn't matter the order that you add stuff. It'll still give you the same. So, plus 40. And what does that tell us that it's going to give us? You can estimate the temperature, right? And so maybe we use T for that. It's really the same as using X and Y, right? Which one of these, if we were using X and Y, which one would be X? Nope. The C, okay? So this is the same as 1/4 X plus 40 equal Y. That's the same thing. A lot of times, most of the time on your test, like when you do PSAT and SAT, they're just going to replace X and Y with the variables that go with the real world thing, right? So that you can know what goes with what. Okay, let's do it again. So and this one, I lied, I guess, a little bit. We are going to do a little bit of getting the answer. So here we go. Concert revenue. This is actually how this works. A concert seating plan is shown below. Reserve seating, so that's down here. I know it's kind of darkened in, but this is like closer to the stage, right? Reserve seating is sold out. So that is gone. You cannot buy those tickets anymore. Right? I'm sorry. Total revenue from ticket sales will depend on the number of general seating. So the ones in the back is sold. Write a function rule to represent this situation. What is the maximum possible total revenue? What's revenue? Profit, right? Money that you make. Okay, so this is sold out, right? Reserve seating. So if it's $25 for a ticket, there's 10 rows and 12 seats per row. How much money did they already make by selling out the reserve seats? Raise your hand if you know how to get that answer. How much money has been made by these tickets here? Go ahead, Speciosa.
Wouldn't you find out like the total seats?
Okay, so how would I find the total seats? Multiply what two numbers? Yeah, 10 and 12. So 10 times 12 gives us 120, right? So 120 seats. How much are they making per seat? So what do I have to do to get the money? Multiply. Okay, 120 seats times $25 each, right? Is $3,000 that they made, because they already told you those are sold out. So they've made $3,000 there. Okay, now what it's going to depend on is this. General seating is $10. There are 30 rows with 16 feet seats per row. Okay, so the first one is to write a function rule, which means an equation, right? So we're trying to figure out our revenue. So we'll say R for revenue is equal to, what did they make already? $3,000. That's what they've already made. That sold out. Are they going to add, subtract, multiply, or divide the next set of revenue? Add it. So plus, and how much are they making per seat? $10 per ticket that they sell, right? So that 10, what does that need? A variable, yeah. Like, and you can pick anything. I'm going to put T for tickets, right? $10 per ticket. So that's right. Now, the second, so this is the function rule, all right? So if they just asked you for the rule, that means what's the equation? And now the question is, what is the maximum possible total revenue? So there's an answer to this. So how many general seat tickets could they possibly sell? How do we figure that out? Yeah, 30 times 16. They can't sell more seats than they actually have, right? Unless they did something with standing room only, but they don't tell us that. What's 30 times 16? What is it? 480? Do 30 times 16, please. 480? Okay. Okay, and then, I know, sorry. I was getting the whole revenue. Okay, so how much money do we make here? Yeah, because we have to multiply the number of seats by what? How much? The $10, right? So 480 seats times $10 each gives me $4,800 that you could make. So the answer to the second question, raise your hand if you know, what is the maximum possible total revenue? What is it, Joelle? How'd you get that? Yeah, this plus this, 3,000 for these seats plus the 4,800 for these seats would give you a maximum of 7,800 would be our maximum total revenue. Right? The funny thing is, you could get that by putting in for tickets, right? By 3,000 plus 10 times the total number of tickets. If we had put 480 in for T, we would have got the same answer. You're really doing the same thing. Okay? We're just doing it in a real world situation, which sometimes our brains don't think in the form of an equation. It's easier. You're figuring it out, but you don't even realize you're doing the equation in your head. Okay? All right, last one. So this is a little more challenging for most students because this is going to give us a nonlinear function rule. So these are all linear, meaning like we have a number, right? And then we're adding or subtracting something with the variable on it. There's no exponents in it. Well, nonlinear means there's going to be either an exponent or you're going to have a fraction with the variable in the denominator, all right? So normally for us right now, where we are in this stage, there should be an exponent if it's nonlinear. So let's look at this one. Write a function rule for the area of a rectangle whose length is 5 feet more than its width. What is the area of the rectangle when the width is 9 feet? Okay, these non-linear ones, sometimes it's a lot easier if you can draw yourself a little picture, okay? So if we're talking about the area of a rectangle, it's real easy. Let's draw a little rectangle. Even I can do that, and my art skills, whoo. Okay, so area of a rectangle whose length, so let's pretend this is the length, is 5 feet more than the width. So what would I write for the length then? 5, then what?
5 times W.
Not times W. More than means plus W, okay? That's this one. So what's my width then going this way?
9 foot.
If we don't know, eventually we're going to figure it out if it is 9 feet. But in general, this is W. Okay, so that's the one that's hard for kids, right? Because if the second question wasn't there, right, and they just want you to write the rule, it tells you in here it's 5 more than the width. So we put 5 plus W. That means the width is W. Okay, so if you get the area, what do you do with this and this? You multiply. Okay, now here's the other part. When I multiply this, I have to do W. I can't just do W times 5 plus W. Don't write that down. You cannot do that. Why not?
Because you have 2 variables.
You have 2 terms. They're 2 variables. You have to do this. This is not right. You have to times by the whole quantity. You got to do W times 5 plus W, like that. All right? Equals, now remember, we're writing the function rule, so that means it's got to equal something. What are we trying to figure out? Area. Okay, equals area. This is the function rule. So a function rule or an equation always has an equal sign. The word equation, means there's an equal sign. Okay, so if it says write an equation or write a rule is an equation. So you need an equal sign. It's got to equal something. All right, now you're right. Now it says if the width is 9 feet, right? Then what's the area? So all we have to do is put 9 in here. We would have to do 9, right? Times 5 plus 9 equals what? Oh, and some of you do it in your head. You know this is 9. What's this then? If the width is 9, what's the length?
14.
And what would you do? 9 times what?
14.
Is that really what you're doing here?
Yes.
9 times 14, right? You're doing it in your mind. And what do you get? And then remember, area is in feet squared. And that's how you do it. Okay, so that's the lesson today. What we're going to do for our assignment is 4-5 practice, which I pulled mine out. Okay. All right, so I want to practice this stuff, okay? It's a lot of doing just translating, okay? There's a couple that you have to figure out, but a lot of it is just translating the rule for the function